If you have any questions about any of the content in this video, just drop a comment down below and I'll get back to you as soon as possible. Enjoy the video. Okay then, let's get started with our first question, which is kind of like the standard example of how you can be asked to apply Pythagoras' theorem to an exam question. So we are told that we've got AB is 6 centimetres, which is labelled on our diagram, and AC is 8 centimetres on our diagram as well. And what we need to do is calculate the length of the missing side BC. Okay, so the first thing, label our hypotenuse, which is always opposite the right angle. So this is our hypotenuse, which we call C for Pythagoras' theorem. We then say C squared is equal to A squared plus B squared. And then we just substitute in our values. So we're going to substitute in C squared is equal to A squared. And it doesn't matter if you label this A or this A. We'll just do that A and B. Doesn't matter which way you do that. Okay, we've then got 6 squared plus 8 squared. So C squared is equal to 36 plus 64, which is 100. And therefore we take the square root of both sides to get C is equal to 10 as our final answer, so 10 centimetres. Okay, question 2, pretty similar, just the triangle has been rotated, which shouldn't put you off really, because the hypotenuse stays opposite the right angle, so we call this C. And we're then told we've got 6 centimetres and 15 centimetres. Okay, so what we need to do is write down our formula. So we've got C squared is equal to A squared plus B squared. Substitute in our values, so C squared is equal to 6 squared plus 15 squared. Okay, and then we've got C squared is equal to, and I'm going to have to grab my calculator for this. So we've got 36 plus 15 squared, which is 261. And therefore we say that C is equal to the square root of this, which is to one decimal place 16.2 centimetres. Just before we carry on with the video, I'd like to remind you that a full in-depth course is available for this topic over on my website. It includes everything you need from the theory to complete worked examples and even your own exam at the end to test yourself. Head on over to benthetutor.com to see all the courses I have available that guarantee your grades will go to the moon. Enjoy the rest of the video. Okay, getting into the next question. The diagram is a little bit different. So we've got a builder places a 3.6 metre ladder against a vertical wall. So here's the ladder and here's the wall. And then we're shown that the gap is 1.5 metres from the ladder to the wall. Okay, so we should be able to spot, we've got a right angle triangle here. That's the thing that we need to spot right away. Okay, right, what do we need to do? So to be safe to use, the base of the ladder must be 1.5 metres away from the wall. The ladder is also placed on flat horizontal ground. How far up to the wall does the ladder reach? So we need to work out this length here basically. Okay, so this time we are given, just drawing our right angle, we are given our hypotenuse C, we'll then call this A, and our side that we need to work out B. Okay, so the first thing is to write down our formula. So C squared is equal to A squared plus B squared. We then need to rearrange for B, so B squared is equal to C squared take away A squared. Substitute in our values, so B squared is equal to 3.6 squared take away A squared, which is 1.5 squared, and then we can say B squared is equal to, and I'll just grab my calculator, so we've got 3.6 squared, and then we've got not plus, take away 1.5 squared, which is 10.71. And then we can say that B, when we take the square root of both sides, is equal to 3.3 to one decimal place. So 3.3 metres is our final answer. Okay, question 7 takes Pythagoras' theorem a bit further. So this question is a bit more complicated because the diagram isn't as simple as your standard right angle triangle. So what are we told? ABC is an isosceles triangle, so ABC is an isosceles triangle. M is the midpoint, and then we've got the distance from A to B is 9 centimetres, which we can see here, and the distance from A to C is 14 centimetres. Okay, and we need to work out the length of B to M. So where's B to M? It's here. Okay, so we've got one side here, which is, if we draw a right angle, opposite our hypotenuse, so we call this C. And then we've got A here and B here, which we need to work out. So we've only got one side at the moment, and we need to work out the second length, which is A. Now, if we're told that M is the midpoint, and we know the whole length is 14 centimetres, we can comfortably say that AM, so this length here, is 7 centimetres. Okay, let's now write down our formula. So we've got C squared is equal to A squared plus B squared. We'll then rearrange this for B, so B squared is equal to C squared, take away A squared. Move down the page a bit. Substitute in our values. So we have C squared, so 9 squared is equal to, let's have a look. That's wrong even. Let's rearrange that. So we've got B squared is equal to C squared, which is 9, so 9 squared. And then we've got take away 7 squared. Okay, so B squared is equal to, let's grab the calculator again. So we've got 81 take away 49, which is 32. So B is equal to the square root of 32, which to one decimal place is 5.7, and the units are centimetres for this one. Just before we get into the next question, if you'd like to get some one-on-one support, just drop me an email over at tutoring@benthetutor.com and we can arrange a session. Okay, right, our next question is again slightly harder. So this time we have two coordinates, 2, 3 and 7, 9. And here we can see them as points in space. And we need to calculate the distance between the 2 points. Okay, right. So let's have a think about this. How can we relate this to Pythagoras' theorem? Well, what we can do is we can join them up first of all. And of course, this is a very rough diagram. And then we can actually make a triangle like this. Again, very rough diagram, excuse the inaccuracy. So now we've got a right angle triangle here. So the next step is to work out the lengths here and here, because we need to work out this length here between the 2 points. So the first thing actually is we should label this C. Okay, how do we work out the length of A and B? Well, to work out A, we need to work out the change in the y coordinates. So 9 to 3 gives us a distance of 6 units. And then to work out B, we need to work out the change in the x coordinates. So 2 to 7 gives us a distance of 5 units. So let's just underline them. Then from here, it's pretty simple. We know how to solve these now. So we need to write down our equation. So C squared is equal to A squared plus B squared. Substitute in our values. C squared is equal to 6 squared plus 5 squared. We then have C squared is now equal to, so 36 plus 25. Let's not make an error, so that's 61. And then we can say that C is equal to the square root of 61, which to 3 significant figures, as they want in the question, is 7.81 units. So the final answer is just 7.81 units. As we don't have any centimetres or metres anywhere, these are just coordinates, so it's just 7.81 without any units. Right, so for our final question, it's going to be quite tough. It's about as difficult as it gets, to be honest, for Pythagoras' theorem. So we've got a triangle, and then we've got 2 triangles within this triangle. And it uses algebra as well, which makes it a little bit harder than if it was just regular numbers, integers, whatever. Okay, so how do we actually solve this question? Well, the question itself says, show that c squared take away 2cx is equal to a squared minus b squared. Now you might be thinking, how on earth am I going to show this? Well, usually with questions like this, you just need to try some things out. The clue is by applying Pythagoras' theorem. So we know that we need to do this at some point, and hopefully we end up with something similar to this. Now the big clue is we've got something equal to something else. So that gives me the indication that these 2 triangles are going to have some kind of relationship. So they're going to be equal to each other in some department. And I can see that they share one length. So this triangle has that length, and so does this one. So maybe if we work out this length for this triangle and for this one, they might be equal to each other and look something a bit like this. So let's give this a go. Let's work out this length for, let's do a different colour. Let's do this triangle first of all. Okay. So first of all, let's just draw a right angle there, and we can label this C as our hypotenuse. So the first thing for all these questions is just write down the formula. So we'll just write it up here actually. So C squared is equal to A squared plus B squared. And then we're going to rearrange, we'll call this A and this B for B. So B squared is equal to C squared, take away A squared. Okay, right, let's now substitute in our values. So we're going to substitute in B squared is equal to C squared, which is just B. So we've got B squared, which is a little bit confusing. We should probably use a different notation here, but we'll go with it for now. I know it's a bit confusing. In fact, no, we really should use different notation. Let's just rub that out. So this is a good point actually. In the exam, don't do this, don't use B squared twice. Let's then call this side, let's call this H. Yeah, let's use H as they have here. So this is equal to, so H squared is equal to, and then the length we've got is B squared, so that's fine now. We've used a different letter. And then we've got take away X squared, which is our A side down here. Okay, so that's the height squared in terms of B and X for this triangle. Let's now make an expression for our second triangle, this one here. So again, we've got our right angle. This is C, and we can't really use C again because we've got C take away X here. So we'll call this, what should we call this? We'll call this the length, so we'll just say L. And then we just need to rearrange, so we can say again, we'll label this H, and then we will say this is A here. In fact, no, we can't use A. It's really annoying how they've done this question because we've got A here, so we'll call this the we'll just say base. Let's make it really obvious, so base, and then we'll change this to hypotenuse HYP. Really annoying that they've used A, B and C, but anyway, just make sure that you use separate terms so that you don't confuse the examiner with what A is, what the hypotenuse is, and so on. Hopefully that makes a bit of sense. I know it's a bit of a mess, but just bear with me, okay? Right, so let's now make an expression for H for this triangle. So H squared is equal to the C squared, and C squared for this one is hypotenuse, and that is equal to A. So we've got A squared, and then we've got take away our B squared, which is our A squared, which is our base, which is C take away X. So then we've got take away, and we're going to put brackets here, C take away X, because that's all squared. It's the entire thing that's being squared. Okay, so we need to do a bit of work here. So we need to expand our bracket, so A squared, then we've got take away, and we're going to keep the brackets here for now to make it a bit easier for ourselves. So we've got C squared, then we've got what have we got, take away 2CX, and then plus X squared at the end. Okay, let's now account for the negative sign, so that's why I put the brackets in, because we have this negative sign to deal with. So A squared, and then we've got take away C squared plus 2CX, and then we've got take away X squared. Okay, so we've got H squared is equal to this, and we've got H squared is equal to this. So now we can combine the two expressions, because we can say that B squared take away X squared from up here is equal to A squared take away C squared plus 2CX take away X squared. Okay, what we're going to do is first of all plus X squared to both sides to get rid of the X squared over here, and when we do that they actually cancel out, so we just get B squared is equal to A squared, then we've got take away C squared plus 2CX. Okay, and what do they want the equation to look like? They want it to look like this. Okay, so what we can do is we want to get the A and B on the same side, so let's do that first of all. So we're going to take B squared over here, so then we'll have 0 is equal to A squared take away B squared take away C squared plus 2CX, And now we just need to get the c squared take away 2cx onto the other side, so we'll do that. So we get c squared take away 2cx is equal to a squared take away b squared. And yeah, that is what they wanted, so we've got there in the end. So, tough question. Whenever you've got two things equal to each other, they must have something in common. It was actually this length here, h. And then just be really careful that you don't confuse yourself as well as the examiner by using c for the hypotenuse, because we've got c here and it just becomes really messy. So use distinct terms. If you have to use multiple letters, for example hypotenuse or base, do so. And then you just need to work out the lengths for both triangles, equate them and solve to get the same form as they wanted in the question.